We have some problems here related to square roots, and the first problem says what could be the possible ones digits of the square root of each of the following numbers. So we have been given some number here, and according to the question these numbers are perfect squares or square numbers. Now it's asking that if you find out the square roots of these square numbers, then what are the possible digits at the units place in each of the following square roots. For example, if you take this number 9801, which is a square number, and let's say you find out its square root. Okay, so it's asking that if this is a square root, and let's say that this is a units place, this is the units place, so what are the possible digits that can come here at the units place? For this, if you remember, we have discussed a property of square numbers, and let's have a quick overview of that. That says if your number ends in 0, then the square number will also end in 0. Now if your number either ends in 1 or ends in 9, then this is a square number, right? This is for the square number. So if your number ends in 1 or ends in 9, then the square number will also end in 1. Okay, square number. Now if your number ends in 2 or ends in 8, then your square number ends in 4. Okay. Now, if your number ends in 3 or ends in 7, your square number ends in 9. Okay. If your number ends in 4 or ends in 6, then your square number ends in 6. Lastly, if your number ends in 5, then the square of this number, that is square number, will also end in 5. Okay, so these are the square numbers. It means that if, let's say that this is 9801, this is a square number, it means that you look for this one, 9801, one here and one here, it's ending in 1. It means that your square root will have either 1 at its units place or 9 at its units place. So for this, either 1 or 9 at the units place. If you look for this one, 99856, so this is a square number, you look for this one, it means that its square root will either have 4 at its units place or 6 at its units place, either 4 at its units place or 6 at its units place. This is 998001, again this condition. Therefore you will say that if you have to tell the square root of this one, then at its units place you will have either 1 or either 9, and in this case it's 5. So look for this condition that says that if your square number ends in 5, then the square root will also end in 5. So at the units place you have 5 here. Okay, find the square roots of the following numbers by the prime factorization method. This is 529. Now this is 529, and this 529 is actually the square number of 23. That is 23 times 23 is equal to 529. Now it's a good, it's good to learn a few square numbers. Like you can learn from starting from 1 to 30 or 1 to 40. That's really helpful. But if you haven't learned that, so first check for 3. Now 9 plus 2 is 11 plus 5 is 16. When you have to check for 3, you have to simply add the digits. If the addition, that the sum you get after adding the digits is divisible by 3, then that number is divisible by 3. No, it's not divisible by 3. Now next check it for 7, right? Because again it has 9 at its end, so possibility is that it could be divisible by 7. 529 is not divisible by 7, also leave that. Now next jump on 11. Okay, check this. Like in this way you have to check, because it has 9 at its end, in the end, therefore there is a possibility that it can be divisible by 11. Again, this is not divisible by 11. Next check for 13. If you check this 529, even 529 is not divisible by 13, right? Because you have to check for the prime numbers. Next, check for 17. If you check for 17, 529 is not divisible by 17. So you go on like that and you will reach at this number 23, and this is actually divisible. So when you find the prime factorization of this is 23. It means that 23 times 23, this is the prime factorization of 529, and this is in pair, therefore the square root is actually 23. Now next number is 5929. So 5929, check whether this number is divisible by 3. This number is not divisible by 3, because if you add all the digits here, you get what? 9 plus 5 is 14, plus 2 is 16, plus 9 is 25. 25 is not divisible by 3. Therefore, ignore 3. Now let's next check for 7, not 5, because this number is surely not divisible by 5. So if you check for 7, this is 5929. If you check whether this is divisible by 7 or not, so 7, 8, 56, 3, you get 2 here, and 7, 4, 28, you get 4 here, and 8, 47. So yes, this is divisible by 7, 847. Now again check for 7 whether this is divisible by 7 or not. So 7, 1, 7, 2, 14, and this is 121. Now this is what? This is 11 times 11 is 121. This we know. So the prime factorization of this number is 7 times 7 multiplied by 11 by 11, right? This is in pair, this is in pair. So when you have to tell the square root, take 1 7 from here and take 1 11 from here. So your square root is 77. So square root of 5929 is equal to 77. For each of the following numbers, find the smallest whole number by which it should be multiplied so as to get a perfect square. Also, find the square root of the perfect square so obtained. Okay. Now here, whenever you are dealing with such questions, where you have to multiply some whole number or divide a certain whole number so that you get a number that is a perfect number, resultant number is a perfect number, always use the prime factorization method. Okay, and in this case, if you look at this number 2028, and if you do the prime factorization of this number 2028, so this is 2028, and clearly this is divisible by 2. So 21202124, this is 2510 and 2714, 3313, then you get 618 and 3927, and now this is 169, therefore this is 13 times 13. Again, learn some squares, that will be very helpful. So here prime factorization of 2028 is actually equal to 2 times 2 times 3 times 13 times 13. Okay, now if you remember, in the part 1 actually we have solved such problems and we discussed in detail. So please watch the part 1 on this video series on problems on square root. Okay, I'll put the video link in the description box below. Now here, this number is clearly not a square number because 2 is in pair, 13 is in pair, but 3, the prime number 3, is not in pair. Okay, it means that if I have to make this number a square number and it's asking that you have to multiply something to this number so that it becomes a square number. Now think that if I make this 3 the pair of this number 3, then this will become a square number. So okay, let's do this. If you multiply this 2028 by 3, then actually you'll get 2 times 2 times 3 times 3, because you are actually multiplying to this number. This is what a prime factorization of this number, so we'll multiply 3 here also. 13 times 13. Now this 2 is in pair, this 3 is in pair, this 13 is in pair, but what's the new resultant number? That's this one. So if you multiply this, 3 8 24, 2 3 2 6 8 3 0 and 6, so your number is 6084. This number you get after multiplying a whole number 3, the whole number 3 to 2028, so that this new number is a perfect square now, right? Similarly, we'll do this for this 1458. Let's do this. This is 1458, and let's do a prime factorization starting from 2. So 2 7 14 to 729. Now this is 9 to 11 plus 7 is 18, so clearly it's divisible by 3. So 3 to 6, 3 4 12 and 3 3 9. You get 3 8 24 and 1, 3 27, 3 9, okay. So prime factorization of 1458 is 2 times 3 multiplied by 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 3. Okay, so we have two different prime numbers here, 2 and 3, but the 3, it has 3 pairs, right? So we have 3 pairs of 3, but 2 is not in pair. So similarly, if you have to make this number a perfect square by multiplying a whole number to this number, then what number you will multiply with by? That number will be 2. So if you multiply 1458 by 2, you actually get, you are able to make this 2 in pair. So now you have 2 in pair, and we already had the 3 in pair. So now this is a square number, but what's a new number? New number is this one. 2 times 8 is 16, 2 5 10 11, 2 4 8 9, and so the new number is 2900, and 2916 is the number that is a square number.